So before we get started, because I know not all of the abstracts might have been well, I'm not going to do that anymore, might have been well explained. So this is part of the software-defined networking track, and in this session we'd like to talk about a very difficult topic that's near and dear to my heart. It's running Lync over Wi-Fi, which is extremely difficult. A lot of customers have found out. And how software-defined networking helps doing this, specifically how software-defined networking does this with the currently certified and qualified vendor, Aruba Networks. So if you were expecting something else, something more fun or less geeky, because this is a level 300 session, so we'll do geeky stuff, this is the time to go, so no one will laugh at you. So if you could turn my mic down a little bit. No, that's fine. I'm loud by myself, so don't need much amplification. I know, Brian. Thank you. So let's start off here, because I like putting my picture in presentations. So you see my picture way more in this presentation, because when you download it at home, you know who that guy is talking, who that guy talking is. So let's start off. I'm not a native English speaker, so I make up words. I make up expressions this morning. I had a new one. So if I say something funny to you, or if I say, if you don't understand me, feel free to laugh at me and raise your hand, and I'll try to explain in a more common language, I guess. So this is me. I'm a voice architect. I work for Microsoft for the Enterprise Communications Center of Excellence. We recently won an award for the largest name possible for a group of people, apparently. Because the complete name would be the Enterprise Communications Center of Excellence for Services Headquarters for the Microsoft Corporation, which is a pretty big line, I guess. I live in the Netherlands. Yes, tulips. I've got a telephony and networking background. I collect Lego Star Wars, the Ultimate Collector Editions. So if you have one and you want to get rid of them, please contact me. Yes, and you'd be surprised how often this works. And I grow my collection again. I've told my girlfriend that they become more valuable over the years, and you can get away with a lot of stuff. See, it's the last session of today, right? So anyway, so I started off with LCS 2003, worked on OCS and Lync. I joined Microsoft like 2.5 years ago. I'm a Microsoft Certified Master on Lync, Certified Solution Master on Lync 2013. That's me in a nutshell. And I'd like to present to you Tainu.
So how are you guys doing today? Last session, glad that it is the last session. I hope you had great information. My name is Tainu Kitapa. I work with Aruba Networks. Really no Lego connections, nothing exotic or exclusive. I've just worked in the wireless and the Wi-Fi industry for the last 10 years. And voice over wireless in particular has been a passion of mine, and hence our engagement with Microsoft Lync. I'm going to let him answer all the harder questions. I'll answer all the wireless questions when they do come up, but thank you for being here right now. Yes, perfect. And self-explanation slide. We've been in the wireless industry for the last 10 years, 11 years. We've had a lot of solutions around enabling mobility in your wireless LAN through products like ClearPass for BYOD. We do a lot of solutions around indoor location finding, and of course we have enterprise-grade, security-enabled, and application-aware wireless LAN solutions. We are pretty much one of the innovators in the Gartner quadrant on both the wired and wireless. Our solutions extend from enterprise products to branch office products, and also the ClearPass product, which is a security product. Any other marketing information you want, you can find us in the booth tomorrow. I'll be more than happy to present this. We're going to try to keep this very, very technical and just give you information on why Lync, why SDN, and why Aruba.
So I'm going to take you through the agenda. So we'll start off talking about unified communications over Wi-Fi and the challenges we've seen in the field and we're trying to resolve when running unified comms over Wi-Fi. How we're using software-defined networking to optimize the Lync experience over Wi-Fi. We'll take a deep dive I'll actually show you a call from beginning to end and how software-defined networking plays a role in that, and we'll talk about a conclusion. There are some lessons learned, so this is a redelivery from this morning. There is a few lessons learned I want to share with you in advance, so we get a few questions out of the way probably. So yes, we had more people in the session in the morning. That's question number one. Question two, yes, we did make Tenu wear the shirt with the raffles. This was not by choice. I'm sorry, I apologize for the shirt. I think if I would wear one, it would make me look really Spanish. I'm sorry. That's fine. So when we're talking about this software-defined networking, yeah, so it's 4:30 for me too, right? It's like in the middle of the night for me actually somewhere. When we talk about software-defined networking, there's a clear delimiter there. We are doing everything we can to help push software-defined networking as the company Microsoft. We take part in the Standardization Council for Software-Defined Networking, and the API we're going to be showing you and be talking about is completely based around open protocols. It is using the northbound API as defined by the Standard Committee. We are not doing anything funny. We're not doing anything strange. It's a very RESTful API we've made, which means that it's just post commandlets in the end. We'll post an XML thing, an XML file with everything we know, and that's it. And in this session, we'll show you how Aruba Networks is using that. So we had a lot of questions about, well, is this only for Aruba? Is this only for, well, no. This SDN plugin, this SDN API, the SDN manager, everything we're going to be talking about is Microsoft and is based on those open standards. The other thing is, we will show you everything about Aruba Networks and how they handle this, how they do this, because it is one of our depth partners, which means Aruba Networks has been with us from the beginning. This is not a sales pitch for Aruba. I'm sorry, I would love for everybody to buy Aruba Network stuff, because then we could do more stuff with them. I don't want you to take that away from this session. We'll show you this based on Aruba, because they are the vendor that currently is qualified and has this. Dell has this as well, because they rebrand Aruba stuff in general. So that's, I just want to... I'll give the clicker to you. That's going to work a lot more easy.
So, to start with, how many of you have more than 3 voice devices or mobile devices? 4? 2 at least? And how many of those devices have Ethernet ports on? Probably one, which is your laptop. And even that you have probably put it on your wired port through the airport or everywhere else. So reason for that is they're all written by different people. Every version of them has a different driver that's being upgraded. Sometimes it's optimized, or somebody who developed the thing's optimized until you put it on an enterprise network and you're like, oh my God, I forgot to turn out power save because it's only saving battery but never getting on the network. So that's the goal. You want to have a network which actually supports multiple different types of devices, and there you want to have communication enablement between the infrastructure, between the devices, and between the application itself, because you get a lot of information on what can be done on the network when the application and devices talk to you. How many of you can relate to this? Anybody who is very familiar with wireless? Does any of that sound familiar on the wired side, wireless side? Anybody is completely convinced that just having WMM certified is completely sufficient to have QoS on your network? Okay, it's just not me. The main reason being, WMM addresses, and they've created standards, right? They've done their job. But at the same time, a lot of implementation is also left to interpretation. And also, there are other aspects of it, like RF management, like tagging on the wired side, which do influence how your WMM performs. And since there is not consistency in your customer deployment base, there is not consistency in how the devices behave, and there is not consistency in all the like 11K, 11R that the clients can implement, there is a need to understand how to optimize the network. With Microsoft's help, we're taking the application information on a network access layer, which is the wireless on our side, and trying to implement features where QoS is implemented on an end-to-end perspective on at least the wireless LAN side. We'll go into the details of how an infrastructure can leverage an API, SDN API information to enable the SDN networks in this session.
I get to talk a little bit about that. So when we talk about networking, especially traditional networking, we have a very clear delimitation between three different aspects. So we've got the intelligence, which is the controller. We've got the thing that does stuff, which is your access point or your router or your switch. And we've got your application. Now, depending on what kind of things you buy, so whether you buy a router for home, an access point for home, that controller and that access point might be in the same package. So you got like this one device. It does, it's not just access point. It also has the intelligence of what it should do as an access point, which means it's a controller and access point in one. And if you have a bunch of those, you'd connect them through a switch, and they use some proprietary protocol to talk to each other. But it's the intelligent, it's directly attached to the access point. Or you can go to a larger enterprise deployment where you have this one big controller and you have a lot of stupid access points, and they get smart because the controller is smart, and they tell them what kind of smart things to do. And then we have the little thing, the child no one wants to talk to in the little corner, which is the application. In this case, it's Lync. So Lync knows about all the clients, it knows everything it's doing, but the controller has no clue what's happening there. The intelligence of the network doesn't know what the application is doing. So we're trying to make the network understand what the application is doing, and we do it this way. We start configuring DHCP markings, we start configuring ports, we set up access control lists, we do all this work to make sure the network knows, oh, if this traffic passes by, it's actually Lync traffic. So now the network understands that certain streams are probably Lync traffic. You're never sure, because it could just be me that hijacks that specific port range because I really like my BitTorrent traffic to go quite fast, and expedited forwarding is a great queue if you want quick BitTorrent traffic. So we'll try to do codec recognition, things like that to battle that. Well, too bad everything's encrypted, so that's not really going to happen. We've seen customers actually turning off encryption, turning off everything off, because then their packet inspection would be able to tag traffic correctly and actually recognize Lync traffic correctly. That's kind of old. I would never really say that's a good plan. And we've learned this week that will actually break your Skype federation. there has to be an easier way to do that. On average, I believe so in my experience, what I've seen at customers, they're working 2-3 weeks to get DHCP tagging correctly working within the network. If I talk to a network team and tell them I need to tag all my link traffic correctly, and they'll tell me, well, it's going to take me 2 to 3 weeks to get that done, and we're testing this and this done, I don't find that number so strange. So there has to be an easier and smarter way to do this, right? So what we're talking about with SDN is taking away that proprietary intelligence on the controller, taking that away from directly connected to an access point or a router or a switch or a firewall, and having that be an open platform, our SDN platform, which is our SDN controller platform. This is the whole view behind software-defined networking. I have this open platform. It has northbound APIs that talk to things I put above the thingy, above the SDN controller, Lync and Skype, in our case, or basically whatever app you'd like, right? So we had a gentleman ask, could we do this with SAP? Sure. If SAP wrote an SDN API, they would talk the same XML files to an SDN controller. It would do exactly the same as Lync does. But now it would say this traffic is SAP. That works. And then we have this SDN controller making informed decisions based on the traffic that's happening and telling the access points or the switches or the routers, this is how you should behave based on the knowledge I have now of both the state of the switches, the state of the access points, as well as the state of the applications. And whether that switch is a physical switch or a virtual switch, as we see in the big data centers right now, doesn't really matter. It can talk to our southbound API directly to a controller. So in short, this whole idea behind SDN is that I will be able to have my SDN controller. That might be a Cisco SDN controller. I like my Juniper routers, so I buy all my routers from Juniper. I like my Brocade firewalls, so I buy some Brocade firewalls. I really love the access points from Aruba Networks, so I buy them from Aruba Networks. And this one little controller has all the intelligence to automatically open firewall ports, configure my load balancers automatically, because Lync is telling them, well, we really need load balancers. Having them configure access points correctly, make sure the access points run correctly, all these nice things. For us, that's complete UC orchestration. It's something we would love to do. We're not there yet. So we go with the things that are possible right now. But this is the dream, right? We've got this open architecture where everybody can connect their applications, everybody can connect their hardware. We use white box switches. We simply have this one intelligent thing that now regulates my entire network. Now let's see, if we look at the solution based on the Aruba Network solution, what they've done, and I really like it, it's quite a smart thing. They've said any wireless controller, so an Aruba mobility controller, that can run version 6.3 point something will be enabled for SDN, specifically for Lync SDN. So if you're currently running an Aruba Networks network and you can run 6.3 point something, everything you're going to see today is possible in your network. So what they've done, they said, well, let's not really build a new SDN controller. Let's enable the existing mobility controller we already have to control our access points. Let's enable that for SDN. So there's an access service running on the controller that listens to Lync, whatever Lync is doing, and then uses that information to make informed decisions for Lync. So we can do things like QS retagging, because we know the kind of traffic that's happening. Lync told them there's traffic happening. Specific app RF for Lync, band steering, load balancing, all those nice things specifically for Lync traffic, because the controller is completely aware of everything that's happening for voice and video. And the beauty of this is, because this is handled by Lync, we don't care whether it's an Android tablet, an iPhone, an iPad, a Windows client. Maybe it's a Windows client someone brought in from home, and you don't have any control over it. Well, Surface RT, anyone? We don't push Windows policies to it, so it's difficult for us to do DHCP tagging. We can do port-based tagging, but, well, that opens the door for the BitTorrent abuse. So we're sort of going with, let's not do tagging at all. Let's be way simpler about that. So enabling Lync on an SDN network in that case would be, I tell Lync I have a controller that's SDN aware. On my controller I'm saying, well, this Lync thing that we've got going on, trust it. It's cool. We've got it covered. And we'll test it. And you're done. The thing I like is that on my screen, this slide looks really different than here. I don't know, there are really gray boxes around the enable SDN integration, ongoing monitoring and troubleshooting. So so you don't think I'm lazy, I actually have a box around it. It's very annoying. Anyway, we enable SDN on Lync. We enable the controller for SDN from Lync, and we're done. We check it, and it's done. The only thing the network team at that point has to do is say, well, I really like my voice traffic to be DSCP tagged 40, my video 56, my my desktop sharing this, my file transfer that. That's all we need to do. And now we've successfully applied QS and everything we need to do with that for all Lync devices within your company. So that sounds like a beautiful thing, right? That saves us so much time and money. So let's take a look if that's actually true, if we've been lying to you. So I'm going to show you exactly what I've done. And I've got a colleague sitting in front, and he can attest to my laziness. So I've done the least, well, with the least cost possible. I've tried to maximize what I could achieve. So what I have and I made sure it was really difficult on me, right? I wanted to get a real solution, because I could demo this to you with like this one access point, and this one controller, and this one Lync server, and this one Lync client, and then have a picture that said that where the controller was running on a different platform, and the controller said everything works, and that'd be quite easy, right? And that would still, well, might prove my point, but I thought let's make it really difficult, and let's make sure that you believe in what I've done. So I have multiple Lync Server 2013 pools. I have a Lync 2013 client, so a desktop client on a wireless laptop. I have the modern app on an RT tablet. I have a wired Lync 2013 client. I'm using the Lync SDN API 2.0, which is the Microsoft Lync SDN API. I'm using different access points, so both the AP135s and the AP225s. And I'm using an Aruba Networks 7200 series controller. It's running software 6400. Little caveat there, that software isn't released. Right now it's 6313 or 14. I'm showing you 6400 by the request of Aruba for the very simple reason it has a very nice monitoring overview. That's the difference. There's no technical difference in the way traffic is handled or tagged as compared to the version that's out now. It's just way prettier and nicer to use. Okay, so we're both using N and AC access points, and the 6400 software is available for customers that like to have this. So this is the overview. Different pools, different clients, different access points. My clients are actually located on different pools to make it even worse. So if I'm a network admin and configuring QS for this, who thinks this is going to be a lot of fun? Yeah, for you, you like networking stuff. This is not going to be fun. This is a difficult setup to get done right. So let's see, and once again, with the least amount of effort, I want to get the biggest advantage here. So let's see what I've done. So I started off with the hard thing. So you see in my picture, there was this Lync role that wasn't really recognizable. It's the SDN manager. It's actually a plain Windows server running .NET Framework 4.5, and I installed the SDN manager. I could have probably reused any other Lync server, but least effort possible. I had an empty server. I installed SDN manager. The only thing I have to do during this installation, it asks me, where's your Aruba controller? Where's your SDN controller? Which I completed here. I used HTTP because I wanted to do some netmon sniffing. I wanted to show some network traces. This completely supports HTTPS, and we would recommend using HTTPS to encrypt this traffic. There's some privacy, some private traffic, some personal identifiable information included. I wouldn't run this without HTTPS, unless you're sniffing. There's a config file included. So you go to this directory, and you can edit the config file if you need to change anything. But the SDN manager is sort of the centralization point where all the information from all the calls is collected before sending this through to the SDN controller. So what kind of information does it have? On every front end, we install the SDN API, which is a service running on the front end and collecting QE information. We do this during call setup and after the call. This QE information gets collected and gets sent to the SDN manager. The SDN manager then takes this information from all the front ends, cleans it, makes sure it's the way we should send it, then sends it to the SDN controller. So some important things in the configuration file. So during the setup, it just asks you, what is the primary SDN manager URI? Once again, I used HTTPS. I would use HTTPS instead of plain HTTP. I wanted to sniff, so no SSL for me. The relevant configuration files here would be the hide PII. By default, this is true. So by default, we obfuscate all SIP addresses. I set this to false because I want a nice integration into my SDN controller. I want to see who's calling who. To get to complete the fullest out of the integration, you have to set this to false. Send all call QE. By default, this is false, which means that only if a call is bad, we would send QE information after the call. We like nice integration where we do where we also report on the good calls. It's kind of bad if you have this picture for your management that says, well, we've got 50 bad calls. So we'd like to show you also the great calls. Send raw SDP and send call invites. Those are used by specific vendors. There are some vendors out there in the hall that you can visit tomorrow again, such as Nectar, who use the SDN API to give you some insights into the call statistics and the quality of the calls. We don't need this for Aruba networks. It's just the hide PII and the send call QE. So we've now configured the SDN API. We've got the SDN manager. We've got all this information being sent to the manager, then to the controller. So now we're going to do the hard stuff, the Aruba Networks controller configuration. So who has configured an enterprise-grade Wi-Fi network before? Have someone? Oh, great. Then I can just press the believe button. I can tell you, it's not easy. So if you thought that access point at home wasn't that easy to set up, think about setting up 5,000 access points on a controller. That's difficult. If you want to do QoS tagging, traffic prioritization, those kind of things. So I'd need you to pay close attention on the setup steps here, because I need to go in and make sure the port set's right. I need to make sure it's HTTP for me now, because sniffing. I need to enable deep packet inspection, and I need to do real-time analysis of voice calls, because I'd like to see the quality during the call, not just after the call. And then we're done. It's that. So that's how I configure SDN on my Wi-Fi controller. And at this point, here's the funny stuff. It actually does everything we need to do. That's all I needed to do. It now gets updates on call setup, types of call. All calls will automatically prioritized on the Wi-Fi. We will actually do AP offloading. If we see too many clients on AP in a voice call and we see APs in the direct neighborhood that actually don't have that many calls running, we'll push clients to different APs. We will show you call performance of all calls. We'll give you a post-mortem analysis if needed of any calls that were bad. Link-aware RF management, all the stuff you really like to have in your environment, but was always very difficult to set up. I've basically done in 3 clicks. That's all there was to it. And I said this morning, and I'll repeat it again, making the screenshots took me like way more than configuring all of this, because I wanted to get the right stuff in there. It getting annoyed with myself because I was like, oh, I got this working. I wanted to play with it. I wanted to get all the logs out, and then I had to take screenshots. So that's that. Now we've got that running. So let's take a look at the call. And I'm so happy that we have one of the subjects of the call in the room now. So we have my use case. I've got my 2 clients. So I've got me sitting here on pool 1, which is actually right over there using 3 different front ends. I've got Thomas, which is sitting on the standard edition. I've got Tenu. I know you're sitting there. I've got Tenu on pool 2, which also 3 front ends. Those are my 3 clients. 2 of them connected through Wi-Fi, 1 of them using the modern Lync app, and the other 2 using the desktop client. So in my case, Cornel places a call to Thomas on a different wireless client and pool. Tenu is invited to this call, video is enabled. Thomas shares some content, and none of the clients are enabled for QoS. It's just a vanilla environment. Once again, lazy admin. I just deployed the stuff, I made sure it worked, and that's it. I didn't do anything else. What would you like to see? That the QoS for wireless is automatically applied, and applied right. So, told you about the pictures in the presentation. That's me making a call to Thomas, and really that's the complete purpose of this slide. That's really all there is in there. So, what's happening now? We're placing this call. So, because we're placing this call, even during call setup, the SDN API picks up on this call. All front ends involved in this call will now start sending information to the SDN manager. So that might be front end 2 on my pool with multiple front ends. It's this one single front end in my standard edition pool. And we send all this information to the SDN manager. And now you can see the reason why we want to collect this information at the SDN manager first before sending this on. Because imagine this being a conference call of 60 people, all on Wi-Fi. Now we might have up to 60 different front ends, all yelling their information to the controller. That's not very convenient. So we want the SDN manager to first make sure the information is in one logical file before sending this to the controller. So we make the call. As the call setup progresses, we inform the SDN manager. SDN manager puts it all together, sends this to the controller. Controller thinks about it, says, well, I know where these guys are at. Let me prioritize the traffic. Let's make sure everything's ready. They're connected to the right APs to make this call a success. So after this call is done, the relevant front-end service actually collect the QE data and send this QE data to the controller. So the controller can do post-call analysis. So I wouldn't believe it just because I said it, so I've got logs. So you can see that this actually works. So this is one of my front ends, and I know this is a very busy slide, so we'll look into, I've got a way bigger font in my later slide, because this is just an example for one of the front ends. It's actually there. I took this using Netmon. I took this post. We talked about this being a RESTful API. It's nothing more than an XML file being posted to the SDN manager, where we have elements like there's Cornel at mslink.nl. He sets up an audio call. There's an element, audio, to Thomas B at mslink.nl. We use IP addresses, ports, the fact that this is UDP. We use codecs. Everything we know about this call is sent to the controller in advance. So the controller knows there's a call happening, might be this codec, might be that codec. The call's on Wi-Fi. The BSS ID that this client is currently associated with, all this information we have, we're all sending it off to the controller. So this is a way cleaner slide. So now we can take a look at some of the nerdier stuff. So this SDN manager takes all this information from all these APIs, all this information he got, he's now reformatting it. So we'll send to the controller, this is an audio call from Cornel with this IP address, this port, to Thomas at that SIP address, this IP address, that port. We'll use the estimated bandwidth, so it might be G722 or Siren or G711 ULAW or ALAW. We might even use For the error correction, we might use RT audio. All these protocols with the minimum and maximum bandwidth, we all send them to the controller. Tell them it's going to be any of those. So the controller is now completely prepared. He knows, well, I might be using up to this amount of bandwidth, right? And if I'm associated with an over-encumbered AP, the controller can now push the client away to a different AP because the controller knows this might be trouble. The call actually flows two ways. We've got an audio stream going from A to B, but also from B back to A. So this is the other way, back from Thomas to Cornel, different ports. We also added video, same thing. Type is video from A to B and all the different codecs. Call has to go back as well, back from Thomas to Cornel, different ports, different IP addresses. All this information is aggregated, is all sending over to the controller. So, Tenu, if you would like to talk about what the controller does with that information.
So one of the main reasons why we started developing the whole SDN API is to create awareness on the network access layer, which is wireless LAN, on how the applications flow and what can the wireless LAN do. Here's some of the ideas on what a wireless LAN can do with the SDN API. So think about information now. All of a sudden, you have your network infrastructure, which is getting rich set of information on what is the application flowing through it, and it's telling you, instead of you guessing, what the priority for this application needs to be, or what is the application type, especially for something like Lync, which has voice, video, desktop sharing, chat, IM, PowerPoint sharing, etc. On the wireless LAN controller, what we are sitting there and doing is looking at the traffic and saying, when it is hitting the wireless LAN controller, is it appropriately tagged? Where we have found when we've done a lot of customer deployments is your wired network has been optimized for your wired phones in past history. So a lot of customers either do not tag the traffic or they're tagging it based on VLANs. In fact, we had a customer walk up to us and say, can I move all the traffic for Lync on a particular VLAN? And we were like, if you want to move it to the voice VLAN? They said yes. I'm like, do you realize that Lync actually has voice, video, desktop sharing, all of this going on that same VLAN, and some of that is not background traffic. And it's a laptop. So if you do a file share, all of a sudden you're sending out traffic on the voice VLAN. They were like, yeah, what can you do, right? It is important when you have a unified device to be able to recognize the different traffic streams and be able to prioritize, because you cannot throw bandwidth through the problem on wireless. The next piece of it is to understand how do you make sure that your LAN between the controller, SDN controller, and the access point is going to relay this traffic tag. And the most important thing is optimizing the traffic in the wireless LAN itself. Things like adaptive radio management that Cornel talked about. How many of you are aware of what radio management does? So if you are in a wireless LAN environment, okay, let me rephrase this. In a wireless LAN environment, you deploy the access point with a certain channel and power level. Do you think that the wireless LAN environment stays the same throughout the day, throughout the year, day after day? In fact, it changes so frequently even within a day. You could deploy an access point in the morning on a particular channel in a conference room, and the characteristics of that room would be different. And then you could have 10 bags of water, which would be 10 individuals walking into the conference room, and your interference pattern changes. Let's even take a more drastic case. Somebody decides that they want to have lunch right in the middle of your conference call, and they're sitting right next to you, and you're in the cafeteria, and they turn on the microwave. Microwave is known to interfere with 2.4 gigahertz. So having a static channel plan in your environment doesn't work for Lync. Changing the channel plan has a challenge because your access point has to go scan the entire network. And if you don't know whether there's a Lync call on the access point or not, there's this user trying to connect to the access point, has voice traffic going through the access point, and all of the sudden the access point says, okay, time for me to go do my other stuff, and is gone for a couple milliseconds. It actually does affect the call quality. So you want your RF management to be voice aware because you want RF management to be enabled. And with the SDN API, you get that kind of visibility throughout the application to do that kind of prioritization. And also, you can do load balancing, so you have multiple access points. You see the load on one particular access point going high. Can you load balance knowing what is the kind of traffic going on this client between multiple different access points to make it optimized? How can you optimize when you have a mix of devices? We have customers who still have .B 2.4 gigahertz devices. So you want to have the 2.4 .B work with 11AC, make sure it's optimized. What if the call was actually happening on the 2.4 gigahertz 11B device? You still want the call to be prioritized. These are the scenarios where getting that information about the Lync call really helps you optimize the wireless LAN access layer. Here's a couple of things where you can quickly see how information from the access point, from the Lync layer does help. So if you look at the highlighted places, as Cornel pointed out, traffic was not intentionally tagged. So here it's 0. But there are a lot of cases where even if you don't intentionally tag, clients do send wrong tags in the upstream direction. And in the downstream direction, you have cases where clients are sending tag where all the traffic is in the VLAN because they decided this is a mobile Lync client, I'm just going to put it into the voice VLAN. On the wireless, if you get all traffic tagged at the same priority level, and it's all going out at the same priority level, you're going to see performance hit because you have your large file share going at the same level as voice, which is more delay sensitive, which is more jitter and packet loss sensitive. You want to be able to identify the voice stream from the video stream from the desktop sharing stream. And with the Lync SDN API, we're able to get that information from the API and implement the QoS based on the different application streams. So what you're seeing here is even though the client came in with really wrong tags, we were able to reapply the tags because we got awareness of the application now. Sorry. Furthermore, you can also see that we recognize the different types of traffic. So you now have visibility on what's going on the wireless LAN infrastructure for the different type of traffic. For this call, if you had extended this screen, you would have also seen packet loss, jitter, delay information on a per AP basis. And even better is, how many of you have end users who call you and say, hey, buddy, I'm having a call problem. Here's my IP address. Here's my MAC address. By the way, I'm running a Lync voice video call with this codec. Can you help me troubleshoot the problem? Normally the call is, hey, I'm having a bad call. My conference call sucked. Can you help me? Right? Now all I need is the person's username. I can list all the devices that the person was using, get call history on all the devices, go into the call history and get detailed stats on the historical call. If they're still on the call, I can do troubleshooting of what the wireless LAN is seeing and also what Lync is seeing because we get that information from Lync. And so now you have a very quick way of saying, hey, as a process of elimination in the next 30 seconds, I can tell you that you're in a bad Wi-Fi area. So I'll go into the details of that quickly, but this is just to highlight that Cornel did the test, and he did see load balancing, so he was impressed with that. But as a wireless LAN vendor who implemented this, we knew this would happen. This is pretty much what I said, right? You never get a call saying, here are the 10 things that will help you debug. It's normally wireless sucks, or Lync sucks, or my device sucks. How can you help me? And the idea here for us is to make sure that if the call is coming into the Lync managers, if the call is coming into the network managers, we provide them with a single platform where they can talk together and troubleshoot the environment. At the end of the day, your Lync deployment is not going to be successful until you can communicate based on common statistics. So this is an example of system overview on what can be done when an access platform talks to an application, right? We can tell you information on what are the call capacity that we get on the device, what is the most common device on which you're seeing Lync. We can tell you what percentage of devices went through course correction in your environment, or even how many of the devices were roaming during a call. Why is all of this important? Somebody calls you and says, hey, I had an issue with the iOS 4.0, it didn't roam properly, or they tell you and you figured out 4.0 doesn't roam properly. Next time somebody calls you, you look at this and you're like, hey, you're on an iOS, and I know iOS devices had course correction problems, so let's look at that first. getting a mapping on performance of the devices, device types, the call type that was having issues helps you troubleshoot and get to a place of, well, you would never have somebody call and say, hey, you guys rock, because you created this rock solid where all my calls were successful. It's normally the complaints. So I'll just say you'll get to a point where you're getting less and less complaints. This is more of a live application chart. Anytime you look into your network, you can get a good idea of how much traffic is video, how much traffic is going to a certain destination, and this helps you plan proactively for your network, right? And we're able to break it out by different streams. For example, Lync Voice is this little box here, Lync Video much larger, and we're able to give you that information, being application aware for Lync now, and you can plan your network and at least give reports saying this is your general consumption on a per AP basis, on a system-wide basis. All you care.
Yes, let's continue with the call setting up. So we've got this call running between Cornel and Thomas, and we are adding desktop sharing, and we're adding Tenu to the call. So let's see if so this is for I'm now guessing you're all aware of the traffic streams within Lync, but let me make sure that I explain that well. So the previous call is peer-to-peer, right? So we had the two wireless clients that were talking to each other. We were prioritizing the traffic, making sure the traffic streamed correctly between the two clients. We're going to complicate it because now it's a conference call. So the traffic, the media is now going to flow through the Lync server to the front end. We're going to actually change modalities. We might change codecs. We're adding this extra client. We're adding desktop sharing. So we told the controller at the beginning of the call this is happening, and we're going to spice it up now. So the controller actually understands this because we'll just send an update through SDN. We'll tell the controller new stuff's happening. And we've told the controller this new stuff that's happening, it's a conference call now. So you'll see that although we made it a new call, so you'll see this is now UCC call ID 9, the previous one was 8. We know that this is still Cornel and Thomas in the call. We know we know that Cornel started the conference in this case. We have all the different destinations, which is either traffic going to the client or traffic going to the front end, because traffic streams two ways. Why would there be only two streams going to the server and multiple from the server back to the client? It's because you can have one party sending, multiple parties receiving. In this case, we'll have the tagging reapplied. So we'll do the same thing as before. We actually recognize that this is a data stream. We recognize that this is video, audio. We'll retag the traffic. In this example, we're actually retagging the data traffic with the same values as video. A lot of customers have told us, well, this desktop sharing you're doing, it doesn't always perform great, and we want to prioritize this as well. So we're giving this the same prioritization by default as video traffic. This is all customizable, so if you'd rather have this in a different QS class, we can do that. Well, actually, Tenu can help you do that. I'm the lazy admin. I just pressed the 3 buttons and it worked. We also recognize that this is now a conference call. Also, desktop sharing is a conference call. And because of this classification, if at any given point people tell you we've got great peer-to-peer calls, but our conference calls suck, we click on the little historical diagrams. You tell them, let's show all the conference calls. And you can see what's happening there. We didn't really talk about this, but we will immediately report on delay, jitter, packet loss, all these things. So 0.61% packet loss for that specific stream, not a client, but a stream, is immediately pointed out. Also, UCC score. So what's the quality of the call? We did the VoIP call analysis. So we'll tell you this is the quality of the call. Also the wireless health of the client. And we'll show you MOS scores for audio. So all this intelligence, all done by the controller, and the only way the controller could do this, because we told the controller, that's a call. You need to be aware, there's a call going to be happening, this is the way it goes. Of course, also the live stream live view is updated. So you can see Lync video, I switched to HD. The Lync video takes up a way bigger portion as before. Lync desktop sharing, also a big piece. And Lync voice, still smaller portion. And we have other kinds of traffic as well. We'll show you there's a lot of unified communications traffic happening. That's the Lync traffic. This is a live view, so at any given time, people are complaining. You can look at your view, and it'll tell you, well, it's because you're using a lot of traffic on your access points, specifically for video. We've added this nice little front end, and because the SDN controller has told them, sorry, the SDN manager has told them, well, this is traffic flowing through this server. We can display the server name, so you know at any given time, okay, conferences to that specific front end would suck or would be great. All this information is handled by the controller to give you the best overview possible of what's happening on your network and acting upon that. Which brings us to the most fun thing in when stuff goes wrong, the active call troubleshooting. I'll leave that to Tenu. She's better at that.
Just really quick, what this will look like in a large scale environment. You will see, for example, the center block, which according to him looks like the...
I thought it looked a bit like the Spanish flag.
The Spanish flag. So if you look at this, essentially we're mapping the Wi-Fi, the call quality health as we get from Lync and from what we observe on the infrastructure with the client health, which is your Wi-Fi health. Ideally, you want all the good calls to be here, but if you see bad calls here, immediately you know that there is a connectivity problem and it is mapping or correlating with Wi-Fi. So you might want to look at the Wi-Fi first. Another classic example is this. When you deploy, you're probably planning for what is the utilization today, right? Conference call, well, there's going to be 3 people in the room, all of them on a bridge. I don't want to scale. And tomorrow, you're looking at this in 6 months, and you're like, oh, wait, there is maximum concurrent call has been 25 for the last 3 weeks. So the utilization of that room is way higher. What can I do to optimize that room? Do we put more access points on A channel? Are we getting, what kind of traffic are we getting? So it gives you a chance to be proactive before it starts really affecting your user performance. The other one is this, which is you're actually now getting a breakup of your network utilization based on device type. You can click on that and it'll tell you calls related to that. All this is actually possible because now we're more aware of voice. So we know what we're looking for when we start making classifications. This is a per client overview. And in an infrastructure, when it is intelligent about voice, we can present you a unified view where we can tell you what's happening on the wireless during the call and what is happening from a client health perspective, a call quality health perspective, right? Once we know for sure it's a voice or a video or a desktop sharing call, we know we have to be aware. Otherwise, you're playing a guessing game. You don't know what the application wants. You're trying to figure out using heuristics or some kind of mapping, a guessing game. Sorry, especially when you're doing encrypted traffic. This gets me with the allergies. The other thing you can also do is view as what's happening on that client during the call. Like he said, he likes BitTorrent. He wants to be the important guy in town. He knows how to manipulate the WMM codes. And he calls you and says, my link quality sucks. Immediately, you look into this and you say, hey, dude, your BitTorrent has high priority. What did you do on your client? Right? And sometimes it's unintentional. In Cornel's case, it is intentional. Cornel, all you.
Well, thank you for suffering through this, at least through my portions. I know it's the end of the day, so my English goes into a me no speaky English version, I guess. It's late. So some of the things that we've tried to show you is that, well, so reality is when people come into your company, they will expect, or your customer's company, they will use wireless. You can tell them a gazillion times, well, you should really use wired. It's not going to happen, right? They have their phones, they have their tablets, they have any device. They have all we've seen. Most people here have multiple devices. I suffer from the same thing. If I go to a company and their official policy is use wired for calls, my official policy is to ignore that and to make calls on Wi-Fi anyway. And I'm afraid that's most people's policy because it works at home, so why can't this work at the company? And this has been hard in the past, hard to set up. And you've seen me do really small steps, just installing an API, enabling an API, and it just worked out of the box. It's that simple because everything that's happened is completely aware of all the traffic. All the controls completely aware of the complete traffic that's flowing. So that Wi-Fi access layer now being aware of all the traffic that's flowing through it, actually knowing that certain streams are audio or video calls, enables that Wi-Fi access layer to respond proactively and intelligently about that. The portion of the better visibility of this Wi-Fi environment. So I used the example this morning about the microwave conference room. So I've been to a customer that had a very nice conference room, but they had really great, really nice table where you could have your laptop and do your conferences. And they had 1 or 2 access points in the air, and every day during lunch, for some reason, all calls sucked. That it just didn't work anymore. And it turns out the lunchroom with like 5 or 6 microwaves was directly attached to that conference room, and microwaves and Wi-Fi isn't fun. So they just couldn't figure out what was happening there. They never thought about looking at the microwaves because they knew there were bad calls. They went to the QE logs, they saw packet loss, and they saw jitter, and they saw stuff happening. But then they had to go to the logs of the controller, and they had to figure out, okay, which client was making the call. They had to write down MAC addresses of laptops. It's just a real horrible experience. And we've seen some of this logging now. We've seen the ease of which you see Cornelius making a call to Thomas. And just zoom on that Cornel guy, and let's see what kind of BitTorrent naughty stuff he's doing. And at what times did the calls suck? Let's filter on times where the calls were bad. Did my Wi-Fi health actually suffer at that point? Could that be the cause? We give you great insight into those things. And it's one of the things, and we see Lync and Aruba Networks is a very happy chess piece, apparently. I'm sure it has a deeper explanation. I just think it's a happy chess piece. It's one of the examples of where a partner steps in, sees the possibility of something we're providing, and gives you a great solution. I'm happy about that they've done that. It's a great addition. We actually see companies switching to a Aruba Networks solution because they give these kind of insights. I'm hoping this drives competitors to do the same thing. I'm sure Tenu is hoping that they don't. Yes, so I agree visibility is always a good thing, just to enable this whole, so this is one of the applications of software-defined networking. We use this for Wi-Fi. As I said, there are many more vendors doing all kinds of cool stuff. I personally think this is a really cool thing. So if you'd like to learn more about this, you can ask me or ask Tenu. I'll be at the booth tomorrow again. You can also go and download and install the SDN API. It's free. It's an add-on for Lync. Go to that website and you can download it. There's the manager, there's the API itself, there's all the documentation you need. There's also a blog written by Jamie Stark about the importance of SDN as a whole and to Microsoft. If you go to the LyncConf website, you'll have your Microsoft account. You can sign in and download and view all the sessions. There's a complete track on SDN, so our vision and futures, different vendors that we're working with is all there. Aruba has a great Lync offering. If you go to the Aruba Networks website, they show you everything they do with Lync, and including this SDN solution. And you can also email the people behind Ruby Networks for some help with your Lync deployment, like RF scanning thingies, network assessments. My English is just going downhill really quickly now. Yes, wrap up. So you can go to the Ruby Networks website, email them, get the RF network assessments, the Wi-Fi network assessments from them, and that gets us done. The one thing I have to ask from you, would like to ask from you, if you're done with today and you're back at your hotel room and preparing for the party tonight that you're all invited to, go to the LyncConf website, go to my Lync, fill in your evaluations, just think about all the nice things we've done and said for you. I would like you to give us a really high score. I'm not allowed to ask that. I'll do it anyway. But it's actually the one thing I really want to ask you is just give us some honest feedback on the sessions we're doing. Give everybody honest feedback, especially Brian and Thomas, because we need feedback to improve them and make sure they aren't as horrible the next time. That's about it. I'm done. I'm really done. So if